Hello guys, welcome to my YouTube channel. Today we are here to solve Leetcode problem of the day, and today is 9 October 2024, and the problem is minimum add to make parenthesis valid. It is basically parenthesis balancing problem. As if you read the statement carefully, you will see, let's say with the example that S is opening, closing, then closing, and then closing, and these are the that sequence of characters, and each character are either opening braces parenthesis or closing parenthesis, and you can insert an opening parenthesis to be something like this, a closing parenthesis to be like this. So you can see that these are closing and respective opening are this one, and closing and opening this one, and this is an extra closing parenthesis. So so this overall string is invalid, and similarly for this one is example is only showing that how you can insert an opening or closing parenthesis. So, and what the problem expectation is, return minimum number of moves required to make S valid. It means that for every opening parenthesis there should be the closing parenthesis. So in the first example, as you can see in the input string, that opening, there is an opening parenthesis and closing, and there is an extra closing parenthesis. So to make it valid, you have to insert an extra, you know, opening parenthesis. That's why the answer is 1. Similarly, in example 2, you can say the input string is only all the characters or only opening parenthesis. So you have to put 3 extra. You have to insert 3 extra closing parenthesis so that you can make it valid. And the constant is 1000, and you can say that each character in the string S either with the opening parenthesis or closing parenthesis. So after reading the problem statement, it is very obvious that it is a classical problem of a stack, where we will we will match for every opening parenthesis, we will match the closing parenthesis. If we will not find any you know a opening parenthesis before any current closing parenthesis, so if no any closing parentheses are available, then you will increase your count, increase the count of insertion, so that you can make the given string as a valid string. So this is all about the problem statement, as I also want to show you that how we will proceed and what will be our approach to solve the problem. So let's begin with a little bit drawing here, how we will, like you have given, like as a string is given like something like opening, then closing. So you can see that these two parentheses are already balanced, so you have to put two extra closing parenthesis so that you can make whole the string as a valid string. So what you have did, because you know that this is already balanced, so we will discard this one. So now you have opening and opening only, so to balance this you have to put two extra closing parentheses. So the answer is 2. And let's suppose that you are have like something like opening and okay, like opening and closing. So these are very similar to this one, so you have to just, if the string given string is this, so what you have to do, this is already balanced, so we will remove this two, and this one is only left. So to balance this we will insert one extra closing parenthesis. But you have like a string something like this one, like 1 and 2, so like this one. So you know that for this closing parenthesis there is no opening parenthesis, so we will have to put some like something extra opening parenthesis here, and to balance this you have to put something like this. So these two will be valid, and these two will be valid, these two will be valid, cancel out, so these two will again valid after the removal this one, and this is already there. So you can find the answer in this way. The best data structure which can give a correct output corresponding to this current program. So you can pause the video and think about how we can do the similar things in which data structure. So all right, you as you might be thinking that we can use stack data structure. Why stack? Because stack you know whenever we will always stack will be like something like this one. It will store the data and we will just speak just see what is available in the top. If in the stack data structure we will only store the opening parenthesis. So opening parenthesis, so whenever we will encounter a closing parenthesis we will check either the stack is already empty or it has some element. And if it has some element, that means that you have encountered some closing parenthesis. To balance it will we can use the current closing parenthesis. So similarly if there is something like opening parenthesis, so something, let's tell you the example, like something this, like this one and this one, like similar, something like this. Okay, so whenever you will hit here, so this is the opening parenthesis, so we will put it here, like 0 indexing 1 2 something like. And whenever again we will get the opening parenthesis, so we will put it here, and again we get, now we encountered the closing parenthesis. So to balance the closing parenthesis we will use this one. So we will remove from here, we will remove this one and we will cancel out something like this. So we will remove this one, and now only you have one single. So we will again get the closing opening parenthesis. So this is opening parenthesis. So what the conclusion after the traversal of each character in the string, that you have two extra opening parentheses. And one more question is like if you have the string something like this, two opening parenthesis and sorry, two closing parenthesis and two opening parenthesis. So you can see that we will not if let's if your stack will be empty and you encounter a closing parenthesis, so you will include that in the answer, like something this is the closing parenthesis, and you do, because the stack whenever you will hit here it is the closing parenthesis but your stack is empty, so in this case you will increase the count, so the count will be 1, and again you will go here and you will say again the stack is empty and you have the closing parenthesis, so you will again include it, and you encounter, now you encounter the opening parenthesis, so you will put it here. We will not increase the count, we will again put here and you will again this one, and now you have traversed all over the string. So to answer, this is the count we got due to the unbalanced closing parenthesis, and these are two extra, opening parentheses that are opening parenthesis. So these two are extra closing parentheses and these are remaining opening parentheses, so we will sum these two, so the answer will be 2 plus 2 equal to 4. As you can also see that to balance these two you have to put it something like these two, and to balance this you have to put something like this one. So this is the classical problem of stack. You can easily think about that how you can implement the solution. So let's try to code it now. So what we can do, we will make an answer variable and I will detail the answer. I will gonna stack and I make a variables to check what is the current character at I. And as I have discussed that if the character is closing parenthesis, so in this case you have to check that if the stack is empty, if not empty, so what you have to do, you have to st dot pop, you have to pop the element, because we are only storing the opening parenthesis. So whenever the stack is not empty, this means that you have already encountered previously a opening parenthesis. To balance it, we can utilize the current closing parenthesis, else we will increase our answer. And in this case, whenever the closing parenthesis, we will push it. So as I have mentioned here, like the answer will be the what is the remaining size of the stack and plus what is the current answer. So the answer will be answer plus stack dot size. So this is, let's start to run it. So these two test cases that are given in the example have been passed, and let's try to submit our code. So you can see that our code have been accepted, and this is very classical easy problem of the stack. So you do not have to worry about it. Just if you know well that how stack is working and how their mechanism and how it store the data and how you fetch the data and how you delete the data, you are ready to go that how you can be able to solve it very quickly and efficiently. So as you can see that our solution beats 58.43% of the people that have been submitted in Java in case of time complexity, and in case of memory constraint you can see that our solution have taken 41.36 MB and beats 64.62% of the people. And let's analysis what is the time complexity. As you have seen that we have used extra space of order n because you are using the stack, and for the time complexity because we are only iterating each character in the string only once, so the time complexity will be linear order of n. So let's try to analyze here. So you can see that our time complexity is order of n. So this is all about today's problem. If you have any query or any suggestion, you can ping me below in the comment box. Make sure to subscribe my channel if you feel that it is very helpful to you, and also make sure to share with your friends who are very eager and need to in competitive programming as well as DSC. So thank you and have a nice day.